This PowerPoint is over experimental design. One of the important things when talking about experiments is knowing the difference between accuracy and precision. First of all, accuracy is getting the right measurement. So if you're measuring something with a meter stick, be able to get the right one every single time. Precision is where you get the same answer over and over again. So in designing an experiment, it is very, very important that you actually complete the same measurement over and over again in order to see consistency in your measurements. If something is inconsistent, then you need to throw that one out and try it again and make sure you're getting consistent. So just to give you a visual of where you can have the difference between accuracy and precision, if you potentially have a lot of measurements that are all in the same ballpark, that would be high precision, but if they're not close to the right answer, then that means they're going to be low accuracy. An example of this is something like if you're making measurements but you're making the same mistake over and over again. So let's say you're measuring something with a meter stick and you don't want to use the end of the meter stick, so you start at 10 centimeters and go over to 16. Well, if you call the measurement 16 centimeters, then you're going to be incorrect every single time, because from 10 to 16 is only 6. So that would be a great example of how you could have high precision but low accuracy, because you're not getting the right answer, but you're getting the same answer over and over again. In order to have high accuracy and high precision, you got to have both of those. You're not making any mistakes and you're getting the same answer over and over again. To have a high accuracy but low precision, this is an example of a student who just really isn't careful with their measurements. And oftentimes, if you're not careful with your measurements, then you can get a wide variety of measurements. If you're consistently trying to be very precise with your measurements, then they should all be about the same ballpark. And then if you have low accuracy and low precision, then obviously you're neither caring nor are you really trying to get consistent measurements. In designing an experiment, there's a lot of things you have to take into mind. First of all, to call it a controlled experiment, this term controlled means that you're only changing one thing that we call the independent variable. And that one thing that's changing is affecting something else that we call the dependent variable. So for example, let's say that you want to see if the amount of water given to a plant will change how high it grows. So in this experiment, you can see that the amount of water is what we're changing. That's our independent variable. And then the height of the plant, that's going to be our dependent variable. Included in that is you have to have everything else to be constant. So while you're trying to figure out how water affects the height of a plant, you wouldn't put one plant in the dark and the other plant in light, because that would be another variable that you would be changing. So everything else would be held constant when you have your independent and dependent variable. Next, you're going to come up with your procedures on how you're going to carry out the experiment and get your measurements. So first of all, you want to make sure your procedures are written in a list and that the measurements are going to be able to be repeatable. So if you have something that you're going to measure, you got to be able to repeat the experiment over again to be able to get the same measurement. You got to be able to do at least 3 trials of each one. So if you're measuring the height of something, you got to do it, measure the height several times to make sure you're getting the same results each time and it's consistent. If you get a height that's not consistent with it, then you throw that one out and try it again, redo a trial. So we're going to talk about how we build a timing device. So we're going to design an experiment for a pendulum. A pendulum is essentially a bob that's at the end of a string and it vibrates back and forth, kind of goes back and forth. And we have an experimental design worksheet that goes along with this. Some possible variables that could change the amount of time it takes for the pendulum to go back and forth. One is the length of the string. Another is the mass of the bob. This thing down here at the bottom is called a bob. And then the amplitude is how much the pendulum is pulled back from this position right here. So those are all possibilities of what could affect how long it takes to complete one cycle. And to give you that definition, that term for that definition is a period. The amount of time for one cycle is the period of oscillation. So we're going to make these 3 things our independent variables, so we're going to do each one separately. So if we change the length of the string, we're going to keep the mass the same and the amplitude the same, but changing the length and see how that affects period. And then we're going to change the mass, but keep the length the same and the amplitude the same and see how that affects the period, and the same thing with the amplitude. So after passing out the worksheet, it's very important that we keep these 3 things in mind when we come up with our procedures for this experiment. So in graphing the data, we're gonna make three graphs. One where each of our independent variables. So let's say, for example, it's length. That's going to go on the x-axis. Independent variable always goes on the x-axis. And the one thing we're looking at what it changes is the period, the amount of time it takes to complete one cycle. So length is going to be on our x-axis. The y-axis is going to be period. And a title that you can give this is going to be the y-axis versus the x-axis. So that's going to be the period versus the length, and that's a good title for this type of graph. If you change the amplitude, if that's your independent variable and looking at period, then it'd be period versus amplitude. Same thing with mass. It'd be period versus mass when you change that. So you're doing all three of those graphs. Now the next experiment we're going to do is a ball bounce. In doing this, we're going to basically bounce a ball and let it jump or bounce back up to whatever height it comes to. So we're studying if we drop the ball from a certain height, how high will it come back up? So we're doing varying heights. So heights from which we're dropped, that's going to be our independent variable, and then dependent variable is going to be the bounce height that it comes back up to. So the graph title is going to be y-axis versus x-axis, so that's bounce height versus the drop height. Now the relationship we're going to see in this experiment is it's going to be a linear relationship, which is going to follow this format. The x-axis again is going to be the drop height that's going to be put in, the y-axis is going to be the bounce height, and then the slope is going to tell us the relationship between the drop height and the bounce height. This will be able to help us make predictions. So if I tell you what height I want the ball to bounce to, then you could plug in that height you want it to bounce to, and then figure out what the drop height is going to be in the process.